Hello and welcome to the Space Above Us. Episode 92, Space Shuttle Flight 25, STS-51L. A Teacher in Space. Last time, we learned about the last flight of the first era of the Space Shuttle program, STS-61C. Columbia returned to flight with more heads-up displays, fewer ejection seats, and a bunch of other upgrades. The flight would be largely unremarkable if not for the presence of a sitting congressman and, of course, its proximity to the flight that followed. The flight that followed was STS-51L, which would prove to be the final flight of Space Shuttle Challenger. 73 seconds after lifting off on January 28, 1986, the vehicle was destroyed and its crew was lost. This is maybe a little more meta than necessary, but ever since I started this podcast, I've been simultaneously looking forward to and dreading this episode. I looked forward to it because it's a fascinating topic that I wanted to learn more about, and hopefully do a good job explaining. But I'd been dreading it because it's just so much. There are intricate technical problems, organizational dynamics, politics, and, well, it's just sad. It's a sad story. With this episode, I hope to do justice to the STS-51L crew and all those hard-working people who strive to keep them safe. I should say right off the bat that the Space Shuttle Challenger accident is a gargantuan topic that I cannot hope to cover in comprehensive detail. It's just too much. While this has varied depending on the mission and my experience with the show, I typically start reading for a flight about 4 to 6 weeks ahead of when the episode airs, with most of my focus coming in the last 2 or 3 weeks. For STS-51L, I've spent my entire life learning about the accident, and began formally researching it at varying levels of intensity for something like the last 9 to 12 months, and I still feel like there's stuff I could learn. So, there's no choice but to pick and choose what's important to talk about and what can be left as additional reading. Rendering the intricate details of any space mission into something approachable and informative is sort of the whole point of the show, but I thought that with this mission in particular, it was important to make that clear. I'll be sure to provide some resources later on for those interested in digging deeper on their own. That said, this will still be a multi-episode mission. We'll be splitting it up into what I expect to be 3 parts. What was supposed to happen, what did happen and why, and how did things get back on track. Today we'll be talking about the first part, what was supposed to happen. This is an idea that got really stuck in my head. If people have heard about the Challenger at all, it's likely that all they know is that the vehicle was destroyed in an accident. You'd be lucky if they even knew the proper name of the mission that was underway, let alone the details of it. I didn't think that was fair. STS-51L was a real mission, a really interesting mission actually, and one that I think deserved its episode just like every other flight. So what we're going to do today is talk about the nominal mission as if it actually happened. I think there's a fine line to walk here. Writing what is essentially fiction about a national tragedy has the potential to not be received the way that I'd intended it. But what I'm going to try to do is give STS-51L the Space Above Us episode that it should have had, all while hopefully conveying the deep respect I feel for the crew, the vehicle, and the mission. Though fiction may be too strong of a word. In order to describe the mission as planned, I will be drawing upon the official press kit, resources distributed as part of the Teacher in Space project, and other materials created in the build-up to the launch. Just to make this explicit, everything leading up to the go at throttle up call is fact, while everything after that point is speculation based on the mission press kit, information about the payloads, and planned crew activities. Alright, that's more than enough preamble. Let's talk about the 25th flight of the Space Shuttle, STS-51L. STS-51L was kicking off what was shaping up to be an exciting year in human spaceflight, 1986. Well, technically STS-61C kicked off 1986, but since it sort of got dragged into 1986 kicking and screaming, I still think of it as a 1985 flight, but maybe that's just me. Anyway, 1986 had a number of important milestones planned that reflected both the growing maturity of shuttle operations as well as the increased confidence in the program. Right away, there was simply the sheer number of planned flights. In 1981, we only saw 2 flights of the shuttle. Moving through the years, we saw 3 flights, 4 flights, 5 flights, and in 1985, 9 flights. For 1986, NASA expected to fly 15 shuttle missions with their 4-orbiter fleet. That's an average of 1 flight every 3.5 weeks. This sort of flight schedule was critical to both keeping the payload backlog reasonably short on what was supposed to be America's only launch system, as well as justifying the large upfront development costs that go into building a reusable vehicle. Without flying regularly, the potential cost savings associated with reusing the spacecraft would never be realized. Also critical in maintaining the shuttle's role as a lone launch provider was the upcoming STS-52A mission, currently planned around the midpoint of 1986. Those who can remember the cryptic mission numbering system will recognize 62A as the first flight of the fiscal year 1986 out of Vandenberg Air Force Base on the West Coast. Space Launch Complex 6, also called SLIC 6, was originally intended to support the Manned Orbiting Laboratory program. Instead, it had been redesigned and rebuilt at considerable cost to the Air Force to launch the Space Shuttle. By launching out of this West Coast site, the shuttle could fly south into high-inclination orbits. You know, the type often used by satellites that want to take lots of pictures of large portions of the Earth every day. In fact, though few knew it at the time, STS-62A payload specialist Pete Aldridge, in addition to being the Undersecretary of the Air Force, was actually the sitting head of the National Reconnaissance Office, the NRO. The NRO is a highly secretive organization tasked with operating the United States' spy satellite fleet. So this flight of the director of the NRO is bound to further cement the relationship between the DoD and NASA. Another important item on the docket was the first flight of some hardware that would considerably enhance the shuttle's capabilities: Shuttle Centaur. Centaur, the venerable rocket upper stage, could probably carry its own podcast. Not just an episode, an entire show. The stage used liquid hydrogen and liquid oxygen to generate massive amounts of energy and unlock the solar system to robotic exploration. It had flown on several different configurations of the Atlas and Titan boosters, but starting in 1986, it would find a new home, nestled in the Space Shuttle Orbiter's payload bay. The reason was pretty simple. Going forward, the Space Shuttle was, by law, America's only launch vehicle. This served to keep the shuttle flying often, driving down its cost per launch, and would save money on each payload thanks to those lowered prices. But since the shuttle could only fly to low Earth orbit, that meant that anything that wanted to go to geostationary orbit, the moon, other planets, or wherever, needed to bring its own source of propulsion. So far, these had been in the form of small, solid rockets. These were preferred since they were so simple. Up until the moment that they were ignited, they basically acted like a big inert lump. But solids weren't suitable for missions that needed a lot of precision or delicate handling, and their propellant didn't contain as much energy as the chemical rocket holy grail, liquid hydrogen and liquid oxygen, or hydrolox. If the shuttle was to continue in its role as the nation's entire launch infrastructure, it needed to be capable of supporting the Centaur upper stage. The trouble with this is that hydrolox stages are incredibly difficult to work with. They were delicate, they required constant topping off and venting. Their propellant would slosh, complicating the orbiter's dynamics, and all of these constraints required extensive modification to the orbiter. Given the volatile nature of the propellants, the myriad anomalous scenarios introduced by the mercurial stage, and the crushing schedule pressure to support time-sensitive missions, there was more than a little concern about the Shuttle Centaur program's impact on astronaut safety. But with Centaur's critical importance, there was no alternative but to proceed onwards with Shuttle Centaur, other than returning to expendable launch vehicles. The shuttle program would get its first taste of just how difficult supporting Centaur would be in a few months with the planned launch of STS-51F carrying the Ulysses solar probe. And rounding out our accidentally not-so-quick look at what 1986 had on the schedule, Space Telescope. The orbital observatory that would come to be known as the Hubble Space Telescope was originally intended to launch in 1983, but, well, you know how things go with aerospace schedules. The 25,000-pound telescope, which was capable of observing light in visible, near-infrared, and near-ultraviolet wavelengths, held the potential to completely change our understanding of the universe. By lofting it into orbit, its nearly 8-foot diameter primary mirror and slew of instruments would have an unfettered view of the heavens. After a far more challenging development than had been expected, Space Telescope was finally ready to start rewriting the science textbooks, with a launch scheduled in August of 1986 aboard STS-51J. Looking at the manifest, we can see that it will be commanded by none other than John Young on what will be his 7th mission. But that's enough about what the rest of 1986 holds. Let's get back to the mission at hand. Commanding STS-51L was Dick Scobie, who we last saw as pilot on STS-41C. While researching this episode, I stumbled across an interesting fact. Scobie was one of the pilots flying the shuttle carrier aircraft that delivered Challenger to the Kennedy Space Center years earlier. This was his 2nd mission, and he was 46 years old. Joining Scobie up front was pilot Mike Smith. Michael Smith was born on April 30th, 1945 in Beaufort, North Carolina. Smith is one of the most piloty pilot astronauts I've ever seen. He graduated from the U.S. Naval Academy and U.S. Naval Postgraduate School before learning how to fly jets and immediately diving into an instructor role at the Advanced Jet Training Command. After that, he flew A-6 intruders around Vietnam, taking off from and landing on the aircraft carrier USS Kitty Hawk. He then did 2 stints at the Navy's Test Pilot School, one as a student and one as an instructor. At the time of this mission, he had flown 28 different types of aircraft and logged nearly 5,000 hours of flying time. The 40-year-old Smith was selected as an astronaut in 1980, and this was his first mission. Mission Specialist 2 was Ellison Onizuka. We know Elle from his flight as a mission specialist on STS-51C. But since that was a classified flight, that's about all we know about his astronaut career. This was a 39-year-old's second flight. Joining Onizuka on the flight deck was Mission Specialist 2, Judy Resnick. We know Resnick from STS-41D, the first flight of Space Shuttle Discovery. On that mission, the crew became the first to experience an RSLS pad abort, with Discovery's main engines shutting down immediately after ignition and before liftoff. Once they made it to orbit, Resnick expertly operated the shuttle's robotic arm to knock an icicle off of the side of the orbiter. This was Resnick's 2nd trip into space, and she was on her 36th trip around the sun. Down on the middeck was Mission Specialist 3, Ron McNair. We last saw McNair back on STS-41B, which is best known for testing the manned maneuvering unit, resulting in some spiffy photos. This is the 2nd flight for the 35-year-old. Joining the main crew were 2 payload specialists. Payload Specialist 1 was Greg Jarvis. Gregory Jarvis was born on August 24, 1944 in Detroit, Michigan. Jarvis earned bachelor's and master's degrees in electrical engineering from the University of New York at Buffalo and Northeastern University, respectively. Jarvis's career touched on aerospace right from the start, with his work on circuits on the SAM-D missile. He also worked as a communications payload engineer for the Air Force's Satellite Communications Program Office. He played a role in the concept formulation and proposal for the SYNCOM satellites that we've been deploying like frisbees for the last few episodes. On this flight, he represented the Hughes Aircraft Company, which is somewhat perplexing since there is no Hughes spacecraft on this mission. In fact, Jarvis had been bumped from a few flights, most recently from STS-61C. There was no Hughes spacecraft on board, but he'd still be doing some fluid dynamics experiments to learn more about the behavior of propellants during satellite deployments. This was the 41-year-old Jarvis's first flight. Despite some remarkable aerospace achievements spread among the 6 people we just discussed, I think it's safe to say that the 7th member of our crew was the most famous. Payload Specialist 2, Krista McAuliffe. Sharon Krista McAuliffe was born on September 2, 1948, in Boston, Massachusetts. She earned a bachelor's degree from Framingham State College and a master's degree in education from Bowie State College a few years later. At the time of the mission, she had been teaching middle school and high school English, history, and social studies for over 15 years. If this sounds like an unusual career for an astronaut, you're right, because Krista McAuliffe is not an astronaut. She was America's first teacher in space. More on that in a moment. Contrary to what is often stated, McAuliffe was not the first private citizen to fly in space. This is actually a sort of tricky concept to nail down, even just looking at NASA. We can start by interpreting it as non-military. In that case, Neil Armstrong takes it with his flight aboard Gemini 8, since he had resigned from the Navy years earlier. Okay, what about unaffiliated with NASA? Well, that goes to Ulf Merbold on STS-9, flying for the European Space Agency. Alright, but that's still related to space. How about first non-military person unaffiliated with NASA or any other space agency. Look no further than STS-9 again, with payload specialist Byron Lichtenberg, a researcher at MIT. First private citizen who wasn't working on NASA-related programs? That gets us Jake Garn. He had a lot of aviation experience, but flew simply because of his position as a sitting senator. But still, this feels different. Krista McAuliffe wasn't a fighter pilot or an astronaut or an aerospace researcher or a senator. She was an ordinary person. And that feels right. An ordinary person chosen to share the spaceflight experience with all those ordinary people who could never experience it on their own. So let's find out how this 37-year-old high school teacher was selected to be the first ordinary person to fly in space. The Teacher in Space project was announced on August 27, 1984 by President Reagan. The goal of the program was simple: choose a teacher and fly them on a space shuttle mission. On their flight, the chosen teacher would present lessons both live and on video, allowing students all over the world to learn more about how spaceflight worked and how everyday life was different in space. Outside of the concrete goals of creating fascinating lesson plan materials, there was also the goal of getting the general public more aware of and supportive of the space program. It was anticipated that the person selected would be shaped by their unique spaceflight experience and continue to share it when they returned to private life. They'd be a sort of spaceflight ambassador. Every year, the winner would shape the minds of a few dozen more students, allowing them the chance to get to know someone who had experienced life in space firsthand. More than a few of those students were likely to have something sparked within them and pursue the science and technology education required to follow in their teachers' footsteps and someday fly in space themselves. It was a feel-good program. It not only rightfully called out the critical role of teachers in our society, but had the potential to change the way that the nation thought about NASA and spaceflight in general by leveraging all teachers' roles as communicators. It also wasn't the only program of its kind. While there's no one better than a teacher at communicating with young people face-to-face, for conveying a message to the world at large, it's hard to beat a journalist. So while a teacher would fly first, journalists were also being considered for a flight later in 1986, with finalists including everyone from Walter Cronkite to Geraldo Rivera. Between December of 1984 and February of 1985, over 11,000 teachers applied to fly. This was eventually narrowed down to 114 nominees, 2 for each state, territory, and other U.S. organizations such as DoD Overseas Schools and the Bureau of Indian Affairs. On July 1, 1985, the 10 finalists were announced. A week later, the finalists traveled to the Johnson Space Center and Marshall Space Flight Center for medical tests and briefings about spaceflight. Finally, on July 19, 1985, it was announced that the runner-up candidate, who would serve as mission backup, was Barbara Morgan from Idaho, and that the primary candidate was Krista McAuliffe from New Hampshire. On September 9, 1985, McAuliffe and Morgan reported to the Johnson Space Center to begin their training. Much like the previous flight, STS-51L suffered a number of delays in the form of 3 postponements and 1 scrub. The first launch attempt was to be January 22, 1986, but that was pushed back a day since STS-61C had so much trouble getting off the pad. The 23rd soon became the 25th and then 26th, thanks again to STS-61C, but this time due to its delayed landing. The attempt on the 26th was called off the night before the launch due to the possibility of rain during the launch window. On the 27th, everything looked like it would be good to go, and for the first time, the countdown got far enough that the crew actually drove out to the pad and strapped into their seats just before 8 a.m. An hour or so later, however, the countdown had to be stopped due to a problem with the orbiter hatch. Since there were no handles or anything on the outside of the hatch, ground crews bolted a metal handling structure to it while on the pad, allowing them to open and close the hatch. The thing is, the handle just wouldn't come off. They eventually had to send for a battery-powered drill to drill out the bolts. And of course, when it arrived, the batteries were dead. By the time the problem was resolved, nearly an hour and a half later, winds had picked up, violating launch constraints. After another 2 hours of waiting for better wind conditions, the launch was scrubbed. These delays strike me as pretty normal. Out of 4 delays, 2 were caused by the unusually problematic previous mission, 1 was caused by weather, and the one scrub was a sort of goofy but ultimately harmless ground equipment issue. But much hay was made of it in the press. I think the combination of the sort of absurd number of delays on STS-61C, coupled with the presence of Krista McAuliffe on this flight, caused the news media to really hone in on the schedule slips. From their point of view, NASA had promised regular airline-like departures. And if you're expecting airline-like operations, these minor harmless delays seem like a pretty big deal. Whether or not it permeated all the way down to the on-the-ground engineers, there was definitely a sense that the nation was waiting for this launch, and any further delays would be noted. For the next attempt on January 28th, the countdown proceeded smoothly and the crew once again clambered aboard their spacecraft. They were likely pretty chilly, since at the time that they were climbing into their seats, the local temperature was hovering around the mid-20 degrees Fahrenheit. To someone from the Northeast like myself, the prospect of mid-20s on a January day doesn't sound so bad. But for Florida, that was staggering. It was easily the coldest launch to date by a wide margin. In fact, it was so cold that large icicles were seen hanging from the pad's service structures, and antifreeze had to be poured into the flame trenches. The ice team determined that the ice on the pad was not hazardous, since there was no way for it to impact the orbiter, but advised delaying the launch by an hour to give all the ice in the area more time to thaw, just to be on the safer side. But finally, the postponements, delays, and scrubs were behind them. The three main engines spun up, the countdown proceeded to zero, the two SRBs ignited, and at 11:38 a.m. on January 28, 1986, Space Shuttle Challenger lifted off for the 10th time. The crew was relieved to finally be flying after the long wait. As revealed on the cockpit voice recorder, not the public air-to-ground radio, pilot Mike Smith called out, "Go, you mother!" And from the back of the flight deck, mission specialist Judy Resnick exulted, "Expletive hot!" Who among us, when truly excited, hasn't shouted expletive on occasion? 35 seconds into the flight, the main engines throttled back to 65% to reduce forces on the shuttle stack as it passed through the period of maximum dynamic pressure. Around this time, Challenger entered about 30 seconds of buffeting by the strongest wind shears yet seen in the program. Wind shear is basically just wind traveling at different speeds and different directions at different altitudes. So if you're rapidly ascending through the layers, you sort of get knocked around. However, despite being the strongest seen so far, it was well within tolerances, and the SSMEs and SRBs pivoted their nozzles to counteract the disturbing force. At 51 seconds, the SSMEs throttled back up to 104% of rated thrust. 17 seconds later, Capcom indicated to the crew that all was well at this significant ascent milestone, radioing, "Challenger, go at throttle up." Commander Scobie replied, "Roger, go at throttle up." A little less than a minute later, the solid rocket boosters separated from the external tank, and Challenger continued on through an uneventful ascent through MECO, jettisoning the external tank and continuing on in a 284-kilometer high circular orbit. First on the agenda was deploying the main payload for the mission, TDRS-B. TDRS, again, is the Tracking and Data Relay Satellite System, with TDRS-B being the second Tracking and Data Relay Satellite. These NASA communications satellites sit in geostationary orbits, which both allows them to see huge swaths of the Earth at once, as well as enable easy downlinking to the primary ground station in White Sands, New Mexico. When TDRS-A was deployed on STS-6, Challenger's first flight, it was a complete game-changer for in-orbit communications. The high data rate and long periods of continuous communication were far superior to the series of short passes over various ground stations. With TDRS-B joining its sister spacecraft, almost an entire orbit would be covered, enabling near-constant communication and data downlink. TDRS-B launched so much later than TDRS-A, partially due to a problem with the solid propellant kick stage that TDRS-A rode to geostationary orbit. Or rather, almost did. The stage malfunctioned, leaving NASA's shiny new communications satellite nowhere near the proper orbit, necessitating a lengthy orbit-raising campaign. But when TDRS-B was deployed 10 hours after liftoff, all systems were nominal, and the spacecraft was soon on its way to its lofty perch. On Flight Day 2, we saw the return of CHAMP, the special low-light camera that would be used to image Halley's Comet. These images would be even more valuable considering that none were taken on the previous mission due to a battery failure on the low light amplifier. I think I caught the press kit authors engaging in a little copying and pasting, since the 51L press kit mentions the crew pointing Champ out of Columbia's windows. That was the last mission, folks. While the mission specialists occupied themselves with Champ, payload specialist Krista McAuliffe got to work on her own tasks. The goal for today was to record a number of short films for use in a classroom setting after the mission. If you've ever had a class where a teacher played a few minutes of a video, then talked about it for a while, then continued the video and kept switching back and forth, you've got a good idea of how this footage would be used. McAuliffe had a number of experiments to film, including demonstrating Newton's 3 laws in microgravity, demonstrating how the classic simple machines behave in space, and demonstrating hydroponic plant growth. This soilless method of plant growth was especially interesting, as it could make it easier for astronauts to potentially grow their own food and could lead to farming advances on Earth. One experiment that caught my eye was a demonstration of magnetic field lines in 3D. I think we've all seen what happens when you lie a bar magnet down on a piece of paper and sprinkle some iron shavings around it. The shavings align themselves on the table along the magnetic field coming out of the magnet. But if I understand correctly, McAuliffe stepped it up a notch. Using a transparent container with a bar magnet at the center and some free-floating iron shavings inside the container, the full 3-dimensional field lines were revealed. Just be careful not to let the iron shavings out of the box. On Flight Day 3, the Spartan Haley mission was deployed. This was another one of these funny little free-flying payloads cooked up by the Goddard Space Flight Center. Mission Specialist Resnick used the robotic arm to grapple the scientific payload, moved it out of the payload bay, and released it. Once Spartan did a little dance to demonstrate that it was working, the two spacecraft parted ways, with a rendezvous and capture planned for the next day. Zipping through the void high above the Earth, Spartan Haley would be able to observe Halley's Comet as it came screaming out from behind the sun. Using a variety of specialized sensors, it was able to study what materials were flowing off of the comet and how they were interacting with the solar environment. These measurements were either impossible or extremely difficult on Earth, since Halley's Comet was still so close to the sun. So any place that could see the comet would be in daytime. Try taking pictures of stars in the daytime and see how it goes. In space, with some precise pointing and specialized optics, Spartan Haley could carefully observe just the comet and would not have to deal with the sun. By having the tiny spacecraft observe both the Earth's atmosphere and the comet using the same instruments, scientists would have something to calibrate to and could further our understanding of these mysterious and ancient heavenly bodies. While Spartan does its thing, let's peek into the now mostly empty payload bay to see what's left. Aha, there's a few student experiments. We're running a little long today, so let's just take a quick look at a couple of experiments that were furthering the educational goals of the flight. One experiment attempted to use semi-permeable membranes to direct how crystals grow. By tweaking the properties of the membrane, it should be possible to change the direction the crystals grow and even their shape. Another experiment heated and cooled a titanium alloy to study how cooling in microgravity affected the material. Up close, metals are formed out of tons and tons of tiny regions called grains. The thought was that by melting the alloy and allowing it to cool in the gentle microgravity environment, the grain size could be increased, leading to an even stronger metal. Perhaps one day, shuttles would be sent up full of jet engine turbine blades to cook in microgravity. And lastly, there was an experiment to study how chicken embryos develop in space. Learning more about how chicken embryos develop in weightlessness could give valuable insight into how human embryos form down on Earth. Oh, and fun fact, this particular experiment was sponsored by, of all things, Kentucky Fried Chicken. As Flight Day 4 rolled around, it was time to rendezvous with and capture Spartan, its brief mission complete. Using its cold gas attitude control thrusters to stay stable, it was an easy target for the remote manipulator system and was soon safely ensconced back in the payload bay. Flight Day 6 was easily the highlight of the mission. At 11:40 a.m. Eastern Time, students in classrooms all over the United States and all over the world turned their attention to television sets, and from far above them, traveling at 17,500 miles per hour, a teacher began to teach. Broadcasting live for the next 15 minutes, Krista McAuliffe led students on what she called the ultimate field trip, making her way through the major features of the crew cabin. Starting on the flight deck, McAuliffe asked Commander Scobie and Pilot Smith to describe their roles as the pilot crew of the spacecraft. She surveyed the controls and myriad switches in Challenger's cockpit, the computers and backup computers, and of course, the view out the aft windows into the payload bay. Next, she demonstrated how astronauts can easily move around in weightlessness by gently pushing off of the walls and floating down to the middeck, where the astronauts eat, work, and sleep. After a quick tour of the crew's sleep stations, the airlock, the storage lockers, and the galley, with the obligatory footage of astronauts eating floating fruit and blobs of water, the crew signed off and the broadcast was over. 2 hours later, it was time to do it all over again, this time with the theme, Where We've Been, Where We're Going, Why. Now that students had an idea of what day-to-day life was like on the shuttle, it was time to answer what they were doing there in the first place. McAuliffe talked about in-space manufacturing and material science, like the science being performed at that very moment in the payload bay. But the promise of ultra-strong and ultra-light metals or new life-saving pharmaceutical products was just one of many reasons to fly in space. Anyone on the ground who's ever played a Nintendo, flown in an airplane, stayed warm while camping, or seen firefighters at work was familiar with NASA's innovations, even if it was a little removed from spaceflight. These so-called spin-offs, like microelectronics, airplane de-icing systems, space blankets, and firefighter breathing equipment, permeate every aspect of modern society. Technology developed for spaceflight benefits everyone. With where we've been covered, what about where we're going? Here, McAuliffe walked through how the shuttle would be instrumental in the construction of the upcoming space station Freedom. Built out of a series of large modules that connected together, it would require numerous space shuttle flights to build America's new permanent outpost in space. 15 minutes passed by, and the lessons were over. With only 30 minutes, NASA not only helped create actually useful in-class material for use by teachers everywhere, but sparked a generation of future engineers, mathematicians, and scientists. As McAuliffe was fond of saying, I touch the future, I teach. Teachers deployed, Spartan retrieved, and lessons taught, it was time to come home. Challenger burned its OMS engines, flipped around to the entry attitude, and began the fiery trip back through the upper atmosphere. Thanks to upgraded nose gear steering, today's destination was the Kennedy Space Center, and since the weather was finally cooperating, STS-51L became the first mission to touch down at the shuttle landing facility since STS-51D way back in April 1985. After 6 days and 34 minutes in space, Challenger was home. As the crew walked down the stairs to the tarmac, the technicians began preparing Challenger for its next flight. The astronauts turned their attention to their next missions, and Krista McAuliffe's career as a sometimes celebrity and always educator was just getting started. Next time, we will sadly put this alternate history back on the shelf and return our attention to reality. What happened to Space Shuttle Challenger? What caused the tragic loss of 7 remarkable people and 1 remarkable spacecraft? What could have been done to prevent it? And what lessons can we learn from it? Ad Astra. Catch you on the next pass.